So now we'll discuss the third question on the concepts of vectors and the properties of vectors. So the question says that the angle between two vectors, okay, the angle between two vectors of equal magnitude is 120 degree. Okay, now we have to prove that the magnitude of the resultant, okay, the magnitude of the resultant is equal to the magnitude of the two equal vectors. Okay, this we have to prove. Okay, so basically we have to use the formula for the magnitude of the resultant vector, which is this: our vector magnitude is equal to p square plus q square plus 2 pq cos theta. Here p is equal to q, the magnitudes are equal according to the question. Theta is equal to 120 degree. So basically the vector will look something like this: P and Q. Okay, two are equal magnitude. Okay, so okay, P vector, Q vector. So this theta is equal to around 120 degree. So here if we substitute the values 120 degree and we write Q as P, so it will become P into P, which will be P square, and here also this will become P. So we have substituted the values. So now it is equal to 2P square plus 2P square. Cos 120 degree is minus 1 by 2, cos 60 degree is 1 by 2, cos 120 degree is minus 1 by 2, ASTC rule, because it comes in the second quadrant, and in the second quadrant cos is negative. Okay, so it is minus 1 by 2. Okay, 2 gets cancelled, this is root over, this is equal to 2p square minus p square root over, which is equal to p square root over, which is equal to p. So our vector magnitude, the resultant vector magnitude is equal to p, but according to the given question, p is equal to q, which is the two vector magnitude. So we have proved this statement that the magnitude of the resultant, which is this, is equal to the magnitude of the two vectors, p equals to q. We have proved. Okay, so all we had to do was to put the values in the expression for the magnitude of the resultant vector, and we got this final conclusion. Okay, so now we'll discuss the fourth question on the concept of vectors and its properties. So the question says that two vectors are of equal magnitude. Okay, the angle between them is theta. Okay, the angle between the two vectors is theta. We have to prove that the resultant vector divides theta equally. Okay, so let me just explain this question. So according to the question, it says that there are two vectors, equal vectors, p vector and let's say it's like this, q vector. Both are of equal magnitude, p is equal to q. They are at an angle of theta. There will be a resultant which let's say is this. Let's say the resultant angle with respect to the x-axis is alpha. So according to the question, we have to prove that this angle alpha is equal to theta by 2. This is what we have to prove. Alpha is equal to theta by 2 or theta is equal to 2 alpha. Okay, both of them are the same. So we have to prove this. The resultant divides this angle theta equally into two parts. Okay, so here as all the discussion revolves around angle, so the angle formula, the angle of the resultant vector, that formula will come into play. Okay, so that formula, I have to erase this part. Okay, so according to that formula, tan alpha, which was that angle which the resultant makes with the horizontal axis or x-axis, that is given by tan alpha is equal to q sine theta. Okay, q sine theta by p plus q cos theta. Now here p is equal to q, so we can substitute q with p sine theta by p plus p cos theta. Okay, we substituted q with p because two vectors are of equal magnitude. So here we can take p common, p plus p cos theta and p sin theta. Okay, p sin theta by p into 1 plus cos theta. We have taken p common. P will get cancelled from both the numerator and denominator. We will get this sin theta by 1 plus cos theta. Okay, now we can write both the numerator and denominator in this way, equal to, okay, here from here I am continuing here, we can write the numerator and denominator as sine 2 theta by 2, 2 times theta by 2. We have written sine theta as sine 2 into theta by 2. 2 will get cancelled and we will get sine theta. So we have modified this numerator as this and will write the denominator as 1 plus cos 2 theta by 2. Cos theta we have written as cos 2 theta by 2. Okay, so here we have two formulas, trigonometric identities, which state that sine 2a is equal to 2 sine a into cos a and 1 plus cos 2a is equal to 2 cos square a. So we'll use these two trigonometric identities. Sin 2a is equal to 2 sin a into cos a. 1 plus cos 2a is equal to 2 cos square a. So this identity will be used here. Sin 2a, here sin 2 theta by 2. So it will become 2 sin theta by 2 into cos theta by 2, and this identity 1 plus cos 2a, here it will be used here, 1 plus cos 2 theta by 2. So this will become 2 cos square theta by 2. 2 cos square theta by 2 can be written as 2 cos square theta by 2 can be written as 2 cos theta by 2 into cos theta by 2. Now in the numerator and denominator we can cancel out 2, we can cancel out cos theta by 2, cos theta by 2. We are left with sin theta by 2 by cos theta by 2. Okay, sin theta by 2 by cos theta by 2. Now sin by cos is equal to tan theta by 2. So if we compare the LHS and the RHS, LHS is tan alpha, this formula, and the RHS is tan theta by 2. So we can equate the LHS and RHS. Tan alpha is equal to tan theta by 2. Tan alpha is equal to tan theta by 2. If we cancel tan and tan, it will become alpha is equal to theta by 2, or theta is equal to 2 alpha. Okay, so we have proved that the resultant vector divides the angle between the two equal vectors, which is theta, equally into two parts. Alpha is theta by 2 or theta is equal to 2 by 2. Theta is equal to 2 alpha. Both mean the same thing. Okay. So we have proved this statement.